Let's go to third problem. Here I am introducing two current sources and to see what happens. Same problem. This is a voltage source plus minus, resistor here, current source here, another current source here. Okay. This is same. I am not changing anything. The only thing I am changing is instead of voltage source I am keeping current source. This was already current source. Okay. And this is Vx, this is Vy, R1, R2, R3, R4, I1, I2, I3. These are the different sources. Here I am not changing the dependent sources. You know why? Because you need to focus on the other parts of the analysis, not on the depend. So straight away go for R2, I2, Vy minus I3, I3. These are the straight away the equations. This is Vs. Now how many equations required? Number of equations required is equal to 3 minus 2 current sources. So we need only one equation. Actually we need 3. Out of that 2 are relations, 1 is equation. And let me first take relations. For example, 2Vx is equal to I2 minus I1. Second, 3Vy is equal to I1 minus I3. These are the two relations over. Then I am going to go for KVL, I1, I2, I3. Because you are taking more than one equation, we still call it a super mesh. Super mesh. In that, as we already said, same thing is valid. R1, I1 minus Vx plus Vy is equal to 0. Plus Vs, minus here, minus there, plus here, over. So these are the 3 equations required. Out of that, 2 are relations. These 2 are relations. This is mesh equations. This is all about this problem having 2 sources, current sources. So as the current sources are increasing, please understand number of equations are decreasing. Let's go to fourth problem. Obtain mesh equations here. You see what I did here. I have taken all 3 current sources. That's why one day this problem came like this. Calculate loop currents without any loop equations. That was the question. And most of the students have said this is out of syllabus. Because we don't need any equations here. 3 equations required, but all the equations are relations. Why? Please look at this problem. Input itself is a source. Itself is a source. Then this is already we have taken. As I told you, I am not changing the dependent sources for a reason that you need to concentrate on the other things. So R1, R2, R3, R4. This also 2Vx, 3Vy. This is also a current source, this is also a current source, this is also a current source. For example, this is 10 amperes. What are the loop currents? I1 over here, I2 over here, I3 over here. Look at that. Now again, if you understand as it is, Vx is equal to R2I2, Vy is equal to minus I3, like this. Always, whenever there is a dependent source, please define dependent sources. Then how many equations required? 3 loops are there, 3 current sources are there. So number of equations required is equal to 0. It's no equation required. That means all are relations. Straight away I am talking to you, answer for this already came. Current in this loop branch is 10. Second one is 2Vx. 2Vx is I2 minus I1. 3Vy is equal to I3 minus I1. These are the equations. Suppose if you put this down, this will be opposite. That's not a problem. So this is how we are not using any equations. Please understand, all are relations. And as the number of current sources increases, it's always good to go for mesh because number of equations are reducing. Okay. No need of equations, straight away answer will come. That's the end of mesh analysis. We will go to nodal analysis. Let's go for nodal equations. The question is obtain nodal equations. As I told you, we only want equations because within 1 or 2 marks we can't solve it. Only equations. The equation that I have taken is this. For example, this is the equation. Apply and get the equations. That's the equation. So what exactly we have is, this is say for example V1, R1, R2, R3, R4, R5, R6. Dependent sources 3Vy, let me say 2Vx. Now I need to define where is Vy, where is Vx. For example, if I define Vx here, okay, then if I define Vy here, how do you get the nodal equations? First, we should understand how many nodes are there. Here is one node, let us say Va, Vb, Vc. This is this. What is a node basically? Wherever there is a division of current, it is called node. If, for example, between these two elements, there is no node because there is no division of current. Between these two elements, there is a node. That's not a node. There is no division of current. That's why wherever there is a division of current, please take it as a node. Okay, as usual, I've been telling, you need to see what is Vx first. Please define dependent sources. Vx is directly Vb because this is Vx, that is also Vb. Now, Vy is directly Vc. So keep these two and then analyze. Vx is Vb, Vy is Vc. Now with this, I am going for nodal analysis. How many equations required? Once again, I am writing that. Number of equations required is equal to number of nodes minus number of ideal voltage source. What do you mean by ideal voltage source? When you say ideal voltage source, that means without series resistance. Without series resistance. Now please look at here. This is a voltage source, series resistance. This is a voltage source, series resistance. This current you know because voltage by resistance. This current also you know because voltage by resistance. This current anyway you know it because that itself is a current. Then how many equations required? Number of nodes available is 3. Number of voltage sources without this, 0. So there is no ideal voltage source. This is not ideal because a voltage source with series resistance is called practical. A voltage source with series resistance is called practical. Please remember, independent source and dependent source, they are treated as same as far as analysis is concerned. Only in synthesis we have difference. But in analysis, independent and dependent both are same. So this is a source, this is a source, but they have their own internal resistance. That's why independent. Ideal is not that. Therefore, how many equations required? 3 equations. So I am going to show you how to go from 3 equations to 0 equations. That's the target of these problems. So let me start with 3 equations. First one, KCL at VA. VA minus V1 by R1 plus VA minus VB by R2 plus that the third branch is directly 2Vx. What is the current in this branch? VA minus V1 by R1. What is the current in this branch? VA minus VB by R2. What is the current in this branch? Directly 2Vx. Over. So that's one equation. Then coming to second, KCL at VB. Okay, KCL at VB. What is that? VB by R3, VB minus VA by R2, VB minus VC. See, between VB and VC there is another source. We need to see that. That is minus 3VY by R4 is equal to 0. Got it? Then KCL at VC. What is KCL at VC? Minus 2Vx, then VC by R5, then what is it? VC minus VB. This is very important. Minus of minus become plus, 3Vy by R4 is 0. That is third equation. So he wanted nodal equations. We gave the nodal equations. Solution is very simple. That is left it. So this is another problem to show how to get nodal equations. So let us go to another problem. Say the same type slightly changed. I would be happy if you can observe what modifications I am doing. This resistance I have removed. That's all. V1, R1, R2, R3. Then R4 I have removed. Then that's why this became R4 now. This became R5. This is 2Vx. This is 3Vy. That's a problem given. And as I've been telling every time, we need to define what is it. Vx, Vy. Get the equations. That equation is Va, Vb, Vc, here. Va, Vb, Vc. Now, how many? First define. What is Vx? Vb. What is Vy? Vc. How many equations required? For example, 3 minus, because there are 3 nodes. How many voltage sources are there? This is the voltage source. There is a voltage source without resistor. When there is a voltage source without resistor, you know what's going to happen? You cannot estimate the current. When you cannot estimate the current, then you can simply, you can't apply KCL. That's why this is called super node. Super node. So that is, how many currents, ideal current sources are there? 1. Now how many equations required? 2. So please understand there's a 2 equations required, means a third one is relation. Actually always you need 3, but some are equations, some are relations, or some are by the KCL, some are by just an equation. So first find out VB minus VC is equal to 3VY. That's the first one. This is a relation. Then I will be going for KCL at VA. When you go for KCL at VA, VA minus V1 by R1 plus VA minus VB by R3, R2 plus 2Vx is equal to 0. Then KCL at VB and VC. It's not one node, it is 2 nodes. That's why when you go for more than one, it is called super node. And when you say that, for example, write, this is very serious and very important, write whatever is linked to VB, whatever is linked to VC. For example, VB by R3 plus VB minus VA by R2 plus VC by R4 minus 2Vx is equal to 0. So how many are involved here? 1, 2, 3, 4. This is called super node. So please look at that way how the solution is going to come. So these are the 3 equations, but out of which one is relation. So when there is a voltage source, normally people think they should go for KVL, but we are going to go for KCL, by which we are going to do it very faster. This is about nodal analysis. So let's go for 7th problem in mesh and nodal. As you observe, I am going to further reduce it. This is 1. This is here. Like that. Now I am converting this as voltage source. This is as it is voltage source. And we will have definitions as it is. Call this as R1, R2, R3, R4. This is Vx. This is Vy. VA, VB, VC. And as usual, this is ground. Ground there. So what will happen is now, when you see, again the same meaning. How many equations? What is Vx? VB. What is Vy? VC. How many equations required? 3 minus. How many voltage sources are there? This is 1. And these 2, another. These 2 are connected, these 2 are connected. So finally 2 are connected here. So how many required? Only 1. So let me write 2 relations and 1 equation. Are you ready? So for example, let's go and see what's happening here. The first one is VB minus VC is 3VY. Then VA minus VA plus VC is equal to 2Vx. Then one equation KCL at VA, VB, VC, all three. Why all three? These two are connected, these two are connected. That means all the three connected. That's called super node. VA minus V1 by R1 plus VA minus VB by R2 plus this is not possible, so only two taken. When you come here, VB minus VA by R2 plus VB by R3, this is not possible, plus VC by R4, 0. Very simply, 1, 2, 3, this is not possible, 2 I took. 1, 2, 3, this is not possible, these 2 I took. Here 1, 2, 3, this is not possible, this is not possible, this is possible, I took only that. Like that, when you really go for calculating, that's the nodal equations if there is more number of voltage sources. So we'll come up with another problem where there is no equation at all. Obtain nodal equations. Actually in this problem it also says nodal equations without any, obtain nodal voltages without any nodal equations. Why? Because you don't need anything. Look at here this problem, how I have chosen. This is V1, this is R1, this is 1, this is 1, R1, R2, R3, 3Vy, 2Vx, Vx, Vy. And this is VA, VB, VC, and here. So this is a problem for us. How do we deal with it? As usual, first Vx is VB, Vy is VC. Number of equations required, how many? This is voltage source without series resistance. This is voltage source without resistance. This is voltage source without resistance. You cannot get a current here, you cannot get a current here, you cannot get a current here. That's why the number of loops are, equations are 0. So that means all are relations. Straight away the answer is V1. Suppose you say this V1 is 10 volts, answer is directly came. Secondly, VB minus VC is 3Vy. Thirdly, VC minus VA is 2Vx. That's all over. So, three equations, there is no equations as such, all are relations. No KCL equations or no nodal equations. They are basically relation of this, relation of this, relation of this. So as voltages increased, as you see, there is no need of any equation equal. That's called the highest and simplest way that you can understand. So let us take the same circuit here. Another inductor, then we will have capacitor. Say this is the problem. So please give the names like R1, L1, C1, C2, R2, L2. How you write the equations for this? For example, you ground it. This is VA, VB, VC. What I suggest is convert them into impedances. See, for example, ZL1 is equal to J omega L1. ZL2 is j omega L2. ZC1 is 1 by j omega C1. ZC2 is 1 by j omega C2. So, keeping that in mind, I am going to really do it. So, this is V of t or V. So, let me apply equations. So, this problem is basically to talk about frequency domain. KCL at VA. VA minus V1, Vs by R1. Call this as Vs plus VA minus VB by ZL1 plus VA minus VC by ZC2, 0. Similarly, KCL at VB. When you say KCL at VB, look at there. VB minus VA by ZL1 plus VB minus 0 because ground is 0 by ZC1, VB minus VC by R2 is equal to 0. Lastly, KCL at VC, VB minus VC minus VB by R2, VC minus VA by ZC2, VC by ZL2, 0. So, at every node I have given the equations. 3 nodes, 3. The whole idea is how to convert L and C into impedance and then put it there. Otherwise, every time you have to do integration, differentiation, it becomes a very laborious. So, convert L and C as impedance, then use that value in the place of R. For example, V by R, it's V by Z. But define them. All this came from conversion of frequency domain or from Fourier transform. So, that is the idea to tell how to write the equations in frequency domain when a bigger problem like this comes. Obtain nodal equations in S domain. So, let us take this as a last problem and 10th problem. Take a source here and a resistor there, inductor, then capacitor, then resistor, inductor, another capacitor, R1, L1, C1, R2, L2, C2, Vs. Let us say that. Now the nodes are, this is a ground, directly we say VA of S, VB of S, VC of S. That's how we call directly into S domain. But what will happen to this one? ZL1 is L1S, ZL2 is L2S, ZC1 is 1 by C1S, ZC2 is 1 by C2S. So, we are already converting L and C into impedances. Now, we are going for equations. KCL at VA, VA of minus VB of S by ZL1 plus VA of S minus V of S by R1 plus VA of minus VC of S by ZC2 is equal to 0. KCL at VB, VB of S minus VA of S by ZL1 VB minus VC by R2 VB by ZC1 0. Then coming to the third equation, we will say KCL at VC. VC minus VB by R2 VC minus VA by ZC2 VC minus or VC by ZL2 is 0. And we need to calculate now, for example, VI of S. If we take inverse Laplace VI of t, like that VB of S inverse Laplace VB of t, VC of S inverse Laplace VC of t. Like that we can calculate currents in time domain also. So these are the equations in S domain. So before going to S domain, convert them into S domain and use that as a KCL. Once you convert them into impedances, you can treat them as resistor, just Ohm's law. So that is where S domain comes into picture and help us to solve. So that's the meaning of mesh and nodal. Therefore, my concluding remarks are very simple. As the circuit becomes complexity, we have to go for mesh and nodal. From mesh we will calculate loop currents, and then we will calculate branch currents and branch voltage. From nodal we will calculate nodal voltages. From there we talk about branch voltage and branch currents. That's how we can calculate. And finally we will always check, as I said in the beginning, sigma Vk Ik is equal to 0, where k is 1 to b. So that is always, anyway, you can cross check. So as the complexity is increasing, examiner will ask you just obtaining the equations. So as once the equations are right, solution will be automatically right. That's the approach for objective exam, whereas for conventional exam, having the equations ready, you can solve it. So getting the equation is objective exam, solving them and getting the answers is conventional exam. So that is how you can appear both for GATE, public sector and IAS. So that ends mesh and nodal.